I'm going to open up with some questions for our panel. And my first question is actually for Joey Ito. How has computer science changed or evolved as a result of increased internet connectivity?
I think the internet dramatically decreased the cost of communication, which decreases the cost of collaboration, the cost of distribution. And then with Moore's Law, you have the cost of computers going down. Then the cost of innovation goes down. So in the old days, and in certain sectors, you still need a lot of money to try a thing. So you have institutions that get built around power, money, and permission. What the internet did was, Yahoo, Facebook, Twitter, they didn't need permission, they didn't need lots of money, and so as the cost of innovation goes down, you have the innovation going and getting pushed to the edges instead of the institutions. And the last thing I'll say is that since it's all connected, it's now a system rather than little pieces. And so I remember when, and Fred's here, but when people were investing in Twitter, we would say, well, that's not a company, it's a feature. But it turns out if you're in a system, a great feature is an important part of the system. And so it encourages a different kind of collaboration when you have a system that you're working in rather than trying to maximize local gain.
Riffing on what Joey said, I think it's absolutely true. Like everything that we think about now, the way that I think we go into developing applications or hardware or whatever, sort of assumes that it's connected to this system and that it's, as you said, like a feature of a larger system. And I think that means that a lot of the interesting computer science problems that you see now are essentially problems of scale, of sort of how do we make an architecture that works with 1 billion users, how do we make a design that works with 1 billion users. And I know when I was in school, right, like a lot of the applications that you would build would be like an OCR for like an envelope or whatever, and it sort of, the capacity of the program was limited to the memory of the program, and you really didn't do a lot of the things that you do now, which is like, oh, you need a database of places, pull in the Foursquare API, you don't even think about it. And I think that obviously changes a lot of the way that we look at computer science and a lot of what we build.
There was a recent article in Forbes about the gender gap in STEM. It said, where are the women? The numbers of women in computer science are continuing to decrease.
The unintended consequences of that piece that we wrote, we are sought out by women who are interested in working in technology and in our IT department as a result of seeing that article on Forbes, as a result of following the comments and the sharing that went on Forbes.com around that piece. And actually, over the last couple of years, it's had a significant impact on the number of interns, women who are looking for internships, and the number of women that we actually hire. We now have a full, 1/3 of our tech team are women. And Jean, I think now that I know you started as a developer, maybe we'll wrestle you in. We've always got a spot for you.
Well, Chris, let me just underscore some of Mike's comments. So I and a few of us really do make a market on understanding why there aren't more women, and we do know why. Guess what? That gender bias occurs starting in grade school. Do you realize if a girl gets a bad grade in some of the STEM, science or math, as in 4th grade is when this happens, 3rd, 4th grade, she drops back, doesn't think she can do it. You know what a boy says? The teacher's stupid and I need to learn this. This is when it starts. We know why. Now what are we doing about it? And it does take men and women to support the effort, make mistakes, get those jobs, make successes, repeat those successes. And so I say to the men in this room and in every room that hears me on this, you as the fathers, the uncles, the brothers, need to understand this and help empower our young people and older on making it happen.
I think I want to give Teresa the opportunity to answer that question.
Well, first I'll say amen. And I feel your passion, Jean. Absolutely. Yeah. And I'll add 2 very specific things that I think can be done that are, and reasons why women turn away, and there's lots of reasons, but 2 key ones. One is social relevance, and the other is an issue of confidence. Women in general want to do work that is meaningful. And computing, unfortunately, has a bad rap of being a person hunched over a keyboard who's very pale because they never get light and sunlight, and there's a sleeping bag under their desk, and they don't have a personality, right? And what middle school girl wants to be that? I know I do. I think I was that in middle school, but we don't really want to strive for that. And so really, celebrations like tonight are about showing how cool the outcomes are of computing, how it's really a creative field, and it's not just about being over a keyboard, but it's about what we can create with technology.
One thing to remember is just 20 years ago, the internet had somewhere between 10 and 20 million users. And today there's probably over 3 billion or so, depending how you count. That's almost half of humanity that's on the internet. So if you write software for the internet, it becomes part of that system that Joey mentioned, and you have a chance to touch half of humanity. That's something that's never existed before in human history. And computer science allows you to do that. There are other engineering disciplines like, how to build a bridge or a plane, which might actually be technically more challenging, but they just don't have the ability to affect as many people as computer science. So that's really exciting to me.
I wasn't very good at education. I'm a 3-time college dropout who ran away from kindergarten. And so, I was good at learning, or I like learning, but I wasn't very good at education. Some people are good at it, so I'm not saying it doesn't work for everyone, and great teachers are great teachers. But I do think that the internet provides a whole new way to learn. And I was lucky because the internet was emerging as I was learning. And a lot of computer science is peer learning, where you're learning, it's kind of master, journeyman, apprentice, working on open source software together. And in a perfect world, it augments. I think what we're doing is we're often missing or not creating a way to learn unless somebody stumbles on it for people who are kind of interest-driven. And I think that the internet provides that. And so I think that it's an and. I think we should augment education with a lot more informal learning that ties back into the system.
It's not good enough for the computer scientists to just use tools to build something, but it's also important that the professionals not solve the problem, but also recognize the problems. So innovate, identify the problems, be able to design solutions, have an appreciation for the user experience, understand the business model, and be able to work with the customer. And so similarly then, at Cooper, we're changing our education so that in addition to the very deep technical skills that we develop in our students, we're also developing their ability to innovate, their understanding of business, their appreciation for design and user experience.
Philippe, what would your advice be to someone that dreams of being an entrepreneur today?
First, live the dream, hopefully. I think the second one is don't do it too early. I think, at least for me, it was very helpful to have learned a few things on the way. I knew even how to take the garbage out at night, And when you do it, really don't compromise. Just do it full speed. Go for it. Anything you have, right time to give it.
So I often see a team, a dream, a PowerPoint, and a dog, and often the dog's not even there. One of the best things that can be done is pull together your own personal board of advisors or board of advisors for the company. I'm allergic to that word project. I want to see a company, a business in formation. All the pieces don't have to be there, but you can get to forming those pieces by putting smart people around you that have the domain expertise or the business savvy, the financial savvy. And then I've advised many early stage entrepreneurs, and it is so hard to get out there and really raise that first capital if you don't have that MVP. I think that's critical for success. So I believe in finding the smartest comrade you can find to build out the product as best you can, even to get it to the point where you have some customers saying, hey, I want to pay real money for this. That's also a game changer. So those are some of the critical things that team around you, that advisory team around you, actually really try with your own skills, resources, and comrades to build out that MVP. And then, you're ready to go find some of those angel investors to get you going. Or like these wonderful events where people can help seed you. That's really a great way to go.
Well, thank you to the whole panel, and I hope that everybody's listened very carefully and will take this advice and go home and encourage at least one student to become a computer scientist so we can get that 2% of the graduates to a much higher percentage.